Models in business analytics. What is a model? Model is an abstraction or representation of a real system, idea, or object. Captures the most important features, can be a written or verbal description, a visual representation, a mathematical formula, or a spreadsheet. Okay, so it can be written or verbal, and also it can be visual. It can be in the form of mathematical formula, okay, like formula for demand, okay, for sales, or a spreadsheet. Example 1.2, three forms of a model. The sales of a new product, such as a first generation iPad or 3D television, often follow a common pattern. Firstly, verbal description. The rate of sales starts small as early adopters begin to evaluate a new product and then begins to grow at an increasing rate over time as positive customer feedback spreads. Okay, do you understand? This is a verbal description on the sales pattern. In the early part of the sale, there was a small start of sale. That means it didn't increase much. Okay, because it's a new product. Customers not know the product much. Okay, I mean not many customers know the product, so few customers purchase the product, and then it begins to grow at an increasing rate over time. Okay, so it's a verbal description of sales of the product. Okay, eventually the market begins to become saturated and the rate of sale begin to decrease. Okay, so the sale of product increase, but after certain period it drops, okay, or begin to decrease. Okay, and then if we want to explain by using visual model, this is the example how we explain the previous sales pattern. Okay, by having the curve. Okay, a sketch of sales as an S-shaped curve over time. Okay, you see from 0 to 50. Okay, there is a slow increase of the sale, and then from maybe 50 to 90, okay, up to 100 weeks, the product increase. The rate of increase is higher, okay, and then after reaching maybe 150, it starts to decrease. Okay, this is how if you want to explain by using visual model. Next one, mathematical model. So it's very simple. For example, S is equal to AE in the power of BE in the power of CT. Okay, so where S is sales, T is time, E is the base of natural logarithms, and A, B, and C are constants. Okay. Okay, next on decision models. What is decision model? It's a logical or mathematical representation of a problem or business situation that can be used to understand, analyze, or facilitate making a decision. So there are three inputs: data, uncontrollable inputs, and also decision options. Data assumed to be constant, and then uncontrollable inputs are quantities that can change but cannot be controlled. That's why we call uncontrollable inputs. And then decision options, controllable and selected at the discretion of the decision maker. Okay, we have options. What type of decision that we want to use or to put on the data. Nature of decision models. Okay, we have inputs and outputs. The decision model will turn inputs into outputs. Okay, so that we discussed before. Inputs involve data, uncontrollable variable, and decision variable. So the outputs will be measures of performance or behavior. Okay, descriptive models. explain behavior and allow users to evaluate potential decision by asking what if questions. Okay, if you do this, what will happen? Okay, on certain situation. Example 1.3 gasoline usage model. Okay, G stand or represent gallons of fuel consumed per month. M miles driven per day to and from work or school. D number of driving days per month. F represents fuel economy in miles per gallon or MPG. A is additional miles for leisure and household activities per month. Example 1.3. Okay, continue. Use dimensions for logical consistency. Miles per day multiplied days per month equivalent to M multiplied D miles per month. Okay. Total miles driven per month equivalent to M multiplied D plus A. Gallon consumed per month M multiplied D plus A miles per month divided by F miles divided by gallon. Okay, equal to M multiplied D plus A divided by F gallons per month. Okay. Example 1.4, an outsourcing decision model. For example, production cost is $125 per unit plus fixed cost of $50,000. Outsourcing cost $175 per unit. Q is production volume. TC total cost, okay, for total cost of manufacturing is equal to 50,000 plus $125 multiply Q. TC for outsourcing is equal to $175 multiply Q. And then for break-even point, total cost of manufacturing is equal to total cost of outsourcing. Okay. So by utilizing the formula or the equation, $50,000 plus $135 multiply Q is equal to $175 multiply Q. Okay, and then we solve for Q. Q is equal to 1,000 units. Okay, so by having 1,000 units, total cost will be equal to total cost of manufacturing will be equal to total cost of outsourcing. Okay, so if Q is less than 1,000, outsourcing is cheaper and vice versa. Okay, and then graphically, this is what we have just now on the equation. Okay, this is the 1,000 units volume. So you see the two lines that we intersect at 1,000 units break-even volume. Okay, beyond 1,000 units, manufacturing is more economical, and then below 1,000 units, outsourcing is more economical. Okay, you see the line, the border is 1,000 units. The next one, predictive models. Predictive models focus on what will happen in the future, from the word predict. Many predictive models are developed by analyzing historical data and assuming that the past is representative of the future. Okay, the past can help us to predict for future. Example 1.5, a sales promotion decision model. In the grocery industry, managers typically need to know how best to use pricing, coupons, and advertising strategies to influence sales. Grocers often study the relationship of sales volume to these strategies by conducting controlled experiments to identify the relationship between them and sales volumes. That is, they implement different combinations of pricing, coupons, and advertising, and they observe the sales that result and use analytics to develop a predictive model of sale as a function of these decision strategies. Okay. In conclusion, in summary, okay, they will use analytics to develop a predictive model by having the past data, current data, okay, all the information, So they will generate or use decision model. Okay, example of the model. For example, total sales equal to 1105.55 plus 56.18 multiply price plus 123.88 multiply coupon plus 5.25 multiply advertising. Okay, see that on the table. If the price is $6.99, no coupons are offered and no advertising is done. The experiment corresponding to week 1. Okay, so you see at the week 1, at the price of 6.99, coupon is 0. Okay, advertising is also 0. Then sale generate at 501. Okay, the first line, first row. So using the model, you can know the sales. So 1105.55 plus 56.18 multiply 6.99 plus 123.88 multiply coupon is 0 plus 5.25 multiply 0, 0 advertising. So it's equal to 1498 something. Okay, $1,498.